All right, so how many of these can I solve and explain in just over 30 minutes? That's how much time I have. We'll find out. The number of states that joined, oh, and let me do it this way so we see fewer questions and the space for the answers. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 900. That's a sentence we can translate. N for, well, okay, I'm just going to translate it for fun. I don't know how useful it's going to be. N, number of states. Let's call it N1. Equals 2 times N2. Right? We've given states joining here and states joining here. Now they give us more information. If 30 states joined the US between 1776 and 1849, so N1 is 30, right? 1776, 1849, that's this. That's what I called N1. So 30 equals, and they're telling us X is N2. So X, they assigned a variable for us. That's 1850 to 1900. Now, did we write this right? 30 equals 2x. That is an answer, right? It's, yep, it's B. Is twice. 30 is twice x. I think it's got to be. But it feels too easy. I'll just pause and check that I'm right. So I think the problem here is that these two answers are equivalent. If we divide both sides of this equation by 2, no, they're not equivalent. Okay, so yes, B is the correct answer. I had it marked incorrectly on the original test, so it incorrectly marked more of you wrong. So if you got this question wrong on 12.2, check again. Actually, 50% of you got it right. So this question shouldn't be on our review assignment, but since I made this video about it, I'm going to leave it here. And yeah, you might have actually gotten it right. I guess I just made a mistake when I put in the answers. So moving on to question 2. The equation above shows how temperature F, measured in degrees Fahrenheit, relates to a temperature C, measured in degrees Celsius. Based on the equation, which of the following must be true? Okay, so the equation, Celsius temperature equals 5/9 of Fahrenheit minus 32, which, this makes sense. Fahrenheit has freezing set at 32 degrees, and in Celsius, that's set at 0. So we first kind of reset it so that the Fahrenheit temperature now starts at 0 by subtracting that 32 from it. And then because Celsius reaches boiling at 100 degrees and Fahrenheit reaches boiling at 216 degrees, we then need to adjust that scale. And that's what the 5/9 does. Okay, so that's the background info on Celsius to Fahrenheit conversions, which I could not have told you if I did not have this equation sitting in front of me. But, hopefully it's kind of common knowledge that 32 versus 0 and that 216 versus 100. And so you've got to do the subtraction and the multiplication. Multiplying by 5/9 makes the Fahrenheit smaller at the scale that Celsius is because it's a fraction. Multiplying by a fraction makes numbers smaller. If you were going the other way, you would add 32 to Celsius, or maybe you'd multiply first. You'd multiply by 9/5, which makes it bigger because that's an improper fraction, not a true fraction, and then add 32. Okay. So this is one of those really messy formatted questions where we now have to make sense of these 3 statements, which there's a typo in, that should say statement 3. And and figure out which of these three statements or which combination of them, because it could be 1 and 2 based on the responses here, is accurate. So let's read them carefully. A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Fahrenheit. Celsius. I think that's true. No, that's not true. Yes, that's true. Yeah, because if we started at 0, at freezing, which is 32 Fahrenheit, this plugging that in, (32 minus 32 is 0. 0 times 5/9 is 0. So that gives us 0 equals 0. 0 freezing in Fahrenheit equals freezing in Celsius. Now we go up a degree in Fahrenheit. What happens? 33. That gives us 1 times 5/9. So in Celsius, that is 5/9 of a degree. How much did we increase from 0 to 5/9? 5/9. So a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. That one is true, which means B and C are not answers. We actually don't have to worry about 3. Again, typo, this should be 3. Because our answer has to have 1 in it. So we now have to figure out whether 2 is correct. If it is, we pick A. If it is not, we pick D. All right, so 2 says a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Okay, so if we're going the other way, we have to flip the fraction. I talked about this earlier. To give us an equation that starts with Fahrenheit and gives us Celsius, we have to first multiply both sides by 9, then divide both sides by 5. So 9/5 Celsius equals Fahrenheit minus 32. Now we add 32 to both sides. 9/5 Celsius plus 32 equals Fahrenheit, or if we rewrite it with the Fahrenheit first, there we go. Okay, well, what is 9/5? Is it 1.8? That's the same thing as 5/5 plus 4/5. 5/5 is 1. What's 4/5 in decimal? Well, we've got to go to 100, right? How does 100 divide evenly into 5? With 20. 5 $20 bills makes 100. So how many is 4/5 out of 100? 0.8. You can do this in a calculator. It goes way easier. You could do it with long division. I don't know if you know how to do long division. Thinking about $20 bills is easiest for me. But yeah, 1.8 is Fahrenheit conversion. So we can do that same question. If we start with 0 Celsius, (0 times 1.8 is 0, plus 32 is 32. We're starting at 0. 0 Celsius, 32 Fahrenheit. Okay, so now we go up 1 in Celsius. (1.8 plus 32 is 33.8. We have increased by 1.8 from our first one to our second one. 2 is true. The answer is A. You do not have to solve it this thoroughly. When I figured it out before, I just looked up whether 1.8 was the right conversion. So this might be enough to convince you that that one's the right answer. Again, these were the hardest questions. Do what you can on them and spend more time if you have it. All right, calculator is now allowed. So I'm going to go ahead and open that tab up. We'll have a calculator at the school you can use. Nate walks 25 meters in 13.7 seconds. If he walks at this same rate, which is the following, closest to the distance he will walk in 5 minutes. Oh, I'm wrong. We don't do meters. It's still meters. We just have to convert from seconds to minutes. How many seconds are in a minute? 60. So 1 minute equals 60 seconds. We need to get a unit rate. So 25 in 13.7 seconds. Yeah, dividing 25 by 13.7 will break that 25 down into 13.7 boxes, giving us how many is in each box. $1.824. So that's how many he walks per second. Let's get that up to a minute. Times 60. That's 1 second. Oh. In 1 minute, that's 109 meters. In 5 minutes, that's 547. So which is the closest? 450. Might have gotten thrown off. You might have thought 547 is closer to 700. It's not. Or you might have gotten the unit conversion wrong. The official way to do unit conversion is to write it out. 25 meters. And we do underneath 13.7 seconds. And then we do times, and we do a form of 1, the one we wrote up there. 1, we put the seconds on top so that it cancels out with the seconds on the bottom. And we do 1 minute. There's a fraction bar here, and a fraction bar here. And we do this so that the seconds cancel out. And we'll be ending up in minutes at the end of that and doing it all at once. So 25 divided by 13.7 times 60 gets us to meters per minute, which is 100. It was 109. You could stop there if you're in a hurry, which you are, you're doing the SAT. Stop there, go about 100, 100 per 5 minutes. Answer is 450. Okay, next question. You all did really well on 11 and not as well on 10. Even though they were both referring to the same information. I thought that was interesting. Planet. Acceleration due to gravity in meters per second squared. Meters per second squared is just a measurement. And this gives us the ratio of gravity on each of these. 9.8 seconds, meters per second squared is the acceleration of gravity on Earth. And we looked at that when we did that chasm question back in the fall. Remember that? This was the rate of gravity we were looking at. Okay, the chart above shows approximations of the acceleration due to gravity in meters per second squared for the 8 planets in our solar system. The weight of an object on a given planet can be found by using the formula W, weight, equals mg, where weight is the object weight of the object measured in newtons, m is the mass of the object measured in kilograms, and g is the acceleration due to gravity on the planet measured in meters per second squared. What is the weight in newtons of an object on Mercury with a mass of 90 kilograms? Okay, so Mercury tells us 3.6 is our G. Oh, 90 kilograms is M. And so we just need to rewrite this. Okay, so W equals mg. W is weight. We are asked weight, so question mark. M is the mass of the object in kilograms. They told us that mass is 90 kilograms. G is the acceleration due to gravity on that planet. We're on the planet Mercury, so it's 3.6. So we just need to multiply 90 by 3.6. Let's do it in this calculator. There we go. 324. That's the answer. I wouldn't be surprised if y'all got thrown off by meters per second squared and you tried squaring things. The trick here is that is a unit, like seconds or miles. That is not math instructions. I don't understand why acceleration is, I'm kind of do, it's calculus. Why acceleration is measured in meters per second squared. Because time is a weird thing to square. But yeah, that's just a unit of measurement. You just have to plug in the bits. There's a lot of extra unnecessary information in this problem. All you have to do is multiply two numbers. The cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equations represents the total cost in dollars for 8 hours of phone use? Okay, they gave you in minutes. You now have to go up to hours. So, 60 minutes, 1 hour. C, cost, equals H, however many hours you spend, times 20 cents times 60. Yeah. So the answer is C. B. The answer is B. It's in a weird order because it's weird to be multiplying 60 by H. I bet you might have read that and gone, oh, that can't be right. But the rate, the 20 cents there, is per minute. So we need to, if you multiply, so you're on the phone for 3 hours. Wow, that was a long phone call. 3 hours is how many minutes? Well, you're going to multiply 3 times 60. It's going to be 180 minutes. And then each of those minutes was 20 cents times 0.20. That gives you the cost. None of the others do. Of the 4 types of savings account plans, which option would yield exponential growth of the money in the account? Oh, in order to put these into the graphing calculator, I did write the equations. That's what happened. Okay, so this was the big thing in our first unit. Exponential growth equation. Your final amount equals the original amount times the growth rate, which is often 1 plus or minus the percentage. I think we usually use R for that, but it is the percentage, to the time power. So, in answer part 1, we are adding 2%. adding is not exponential, only multiplying is exponential. So that would be, and it's also the initial. So what they're doing there is they put in an amount and it's plus 2% of that. And that's the same every year for the original amount, the initial savings. For it to be exponential, it has to be 2% of the current amount that includes last year's added growth. So that's why it keeps growing bigger and bigger and bigger, is because instead of just growing a certain amount every year, the same amount, plus 10, plus 10, plus 10, plus 10, great, but that's how you earn money with a job. How you earn money with interest is plus 10, and then next year it's plus 11 because it's 10% of your original amount and 10% of the $10 you earned. And the year after that, it's going to be more. A is not exponential. Same thing with B, the percentage is on the initial saving, and the 100 is just a plus 100. That's not being multiplied by anything. If it's adding, it's not exponential. I know I graphed this when I was confused by it before, but now this is not. Okay. Again, added. So exponential is only when it's percentage of the current value. And I wasn't sure if 1% was even a growth rate, so I think that's why I wrote the equation. So original amount, let's say it was $100. We have our growth rate, it's 1 plus 0.01 to the t power. I had to make up a starter amount or this equation wouldn't work. You can see that that's exponential. We did a lot on this in Unit 5, so you can go back there if you want some more reviews. Okay, I have like 10 minutes left to make this video. I'm not bad though, we only have 14 questions, and I'm up to question 7, so I did half. Maybe I'll have time later to do more. Okay, the sum of 3 numbers is 855. One of the numbers, x, is 50% more than the sum of the other 2 numbers. What is the value of x? Notice we do not have to find all 3 numbers. We just have to find x, which is the one that is 50% more. Okay, so let's assign variables. Number 1 is A, number 2 is B, number 3 is C. A is our, wait, no, sorry. A, B, and X, as they gave us X as a variable. X equals and there's 2 ways to think about that, and I can't remember which one I decided was right. Okay, I hope this explanation makes sense. I thought about it for a good minute off camera. X is 50% more than the sum of the other 2 numbers. That 50% more is a plus. And then A plus, the sum of A of the other 2 numbers is A plus B. Now it's 50% of what? It's 50% of A plus B. Or it's 50% of X. No, it's not 50% of X. It's 50% of A plus B. So it's the sum of the other 2 numbers plus 50% of that again, right? See how I have that here? X is, so X equals the sum of the other 2 numbers plus 50% additional. The other way you can think of this, because 50% is not a number we can do math with, 0.5 is. We can rewrite this as 1 times A plus B. I have not changed the value here by doing this. I'm just calling out what's happening. We have 1A and we have 1B. This is one set of A plus B. And over here we have 0.5 sets of A plus B. We can add those up. This box has A plus B in it, and this box has A plus B in it. This box is just half a box, and this is a whole box. So altogether, I have 1.5 boxes that contain A plus B. Now this is a beautiful, simple equation that we're gonna be able to solve, as long as we keep in mind our other equation, which is A plus B plus X equals 855. Okay, we now have two equations. It is a system of equations. We will isolate and solve. In fact, we're actually just going to plug in because we have X isolated already, and that's the one we want to solve for. Is it? Okay, so there's this thing called U substitution, and of course, last minute SAT prep may not be the best time to introduce a new concept. But I think it really helps with this problem. I've already kind of been alluding to it by calling A plus B a box. You notice we're doing a lot with A plus B. We're doing nothing with just A or just B. So U substitution is called that because what we're going to do is say, actually, this is a different thing. Yeah, there's little parts to it, but it always acts as a unit, and so I'm just going to call it U. Because we're told nothing about A and B by themselves. We're just told that they get added up with X to make 855, and they get times by 1.5 to make X. So my new equation reads U plus X equals 855, and X equals 1.5 U. All right, so we plug in 1.5 U here, because that is the same thing as X. That adds up to 2.5 U. We divide both sides by 2.5. $342. Now, we were already told X is the biggest number, and that U plus X equals 855. So at this point, all we have to do is subtract 342 from 855. $513 should be our answer, and it is one of the options. Love when that happens. If you don't use U substitution, you might just get stuck on trying to find A and B. This problem does not require you to find A and B. It requires you to find X, and it actually doesn't tell you enough information to find A and B. They could be any two numbers that add up to make 342. So I actually kind of think the U substitution is really important, or at least noticing that you do not have to solve for A and B. So good luck. That's hard. That's like a very, it takes a creative leap to get there, I think. You're totally capable of it with some close reading, but do your best. There might be a way to guess and check this. But it'd be something I'd recommend saving if you feel really uncertain on a question like this. Do the other ones first. Let's see if I can get one or two more questions done before I have to go for my next office hours. Okay, Mr. Cole has a beaker containing n milliliters of solution to distribute to students in his chemistry class. If he gives each student 3 milliliters of solution, he will have 3 milliliters left over sorry, 5 milliliters left over. In order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. How many students are in the class? This is a classic example of the kind of algebra question that students make memes about, going, why should I care? And how did we get to students when we were talking about milliliters the whole time? It is there. Each of these datas that they're giving us is about the number of students in the class, but it's not obvious immediately. So let's write some equations. N, they gave us a variable. It's the number of milliliters of this whatever it is for chemistry. If he gives each student 3N, he will have 5 milliliters left over. Okay, so we need another variable. We need S to be students, right? Assign variables is our first step dealing with these. So N equals number of milliliters of solution. S equals number of students in class. Now we write equations. So student times 3, right? Each student is getting 3 milliliters. That adds up to all the solution he's using. And he's going to have 5 milliliters left over. So plus 5 equals N. N is the total solution milliliters he had. He's going to have 5 milliliters left over. So that goes on the other side to make the total equal the total. Another creative leap. But it's true, right? If you put it on this side, you'd end up unbalancing it, and the whole solution plus the extra would be more than the solution you started with, and it wouldn't work. Okay, so next bit, in order to give each student 4 milliliters of solution, he will need additional 21 milliliters. So same start, 4S, 4 milliliters per student minus 21 equals N. Or we could do N plus 21. We could actually do this here too. That might make more sense. So the 5 left over, you'd have to take away. If you threw away 5 milliliters, then N would be enough for 3 milliliters per student. Okay, you've seen it before, system of equations, solve it. Whether you isolate S on both of them, make them equal to each other, or you add them together, make one negative, make N go away. This is solvable, and I'm out of time. If I have time, I will answer 9 through 10. Hopefully this is enough to get you feeling more confident about word problems. Best of luck.